Hello everybody, today we are going to explain the topic about circular measures. So first, we get to know the parts of a circle. The first is the diameter. Diameter is equal to 2 radius, and a radius is a line that connects the points from the outer circle to the middle point of the circle. Next is a sector. Sector is the portion of the circle enclosed by 2 radius and an arc. Arc. Arc is a curved line that connects 2 points of a radius, as you can see in this picture. A chord. Chord is a line that connects the end points of an arc. Segment. Segment is a region bounded by a chord of a circle and the intercepted arc of the circle. And here there's also some additional information about secant and tangent. Secant is a line that intersects the curve at a minimum of 2 distinct points, while a tangent is a straight line that touches the circle but if extended does not cross the circle.
Now we are going to watch a short video together to know more about our first topic of circular measure, which is radian.
Now that we know all the different parts of the circle, let's get into the concept of radius. What is radians? Radius is just a unit for angle. So instead of degrees, we also have radius. Now how is one radian defined? One radius, now let's mark the angle first. So we are looking at the angle subtended at the center of a sector like this. Now this angle is known as 1 radian if the length of the arc, so we are looking at the minor arc, when the length of arc is the same value as the radius, then the angle is 1 radian.
Radians are defined so that the angle made at the circle of a radius 1 unit is the same as the length of the arc. Now I will show you how to turn degrees into radian and radian into degrees. Turning degrees into radian. Theta degrees equals to theta degrees times p radian over 180 degrees. Now turning radians into degree equals to theta radian equals to theta radian times 180 degree over p radian. Now we want to find the length of arc. To find the length of arc, if the angle is in degree, we use this formula: theta degree over 360 degrees times p times 2 times radius. While if the angle is in radian, we use this formula is radius times theta radian. Now here are example question of finding the length of arc. If the radius is 50 cm and theta equals to 30 degree, answer in term of p. So now I will show you example question of finding the length of arc. So in the question there are 30 degree and 50 cm as the radius. Find the length of arc in term of. So the formula of finding the length of arc in degrees of theta degree divided by 60 times p times 2 times radius. Theta is the angle, so the angle is 30 degree divided by 60 degree times p because in term of p times 2 times 50 centimeters. So now we're gonna cross the p with 360 equals to 1 over 4 and go 10 plus by 2, so 1 over 6. 6 plus by 50, so divided by 2, so 3, 1 over 3 times 25. So 1 over 6 times 3 times 25 centimeter equals to 25 p divided by 3 centimeter. Yeah. Next is finding the area of sector. If the angle in degrees, we use this formula: theta degree over 360 degree degree times area of circle, which is B times R times R. If the angle is in radian, we use this formula: half times radius square times theta radius. Now here are the example of finding the sector area if the radius is 20 cm and theta equals to P over 2. The answer must be in terms of P.
Now I will show you example question about finding the sector area of a circle in terms of P. So the angle is 4 over 2 radian and the radius is 20 cm. So the formula of finding the sector area in radian is half times radius square times theta radius. So half times 20 square and theta radian is P. So 1 over 2 times 20 times 20 is 100 times P over 2. So we can put out half times 200 and 200 can cross over 2 equals to 100. So 100 times P equals to 100 P centimeter square.
So now we are going to discuss how to find the area of a segment. So as we all know, how to find the area of the segment is to minus the area of the sector with the area of the triangle. So as we know, the area of the sector formula is half R square theta. Minus with the area of the triangle. So to know the area of the triangle, we need to remember the formula of AB sin C. Now we are just going to convert this formula. So the AB here will be the radius, so half R square, and the C here will be the theta, sin After that, all we need to do is factorize this formula and it will become half radius square times in the bracket theta radius minus sin theta degrees. Now we're going to do example question. Find the segment area if the radius is 10 cm and theta is equal to 30 degrees. So now I'm gonna do a simple example of how to find the area of the segment. So the area of the segment is basically the area of the sector minus the area of the triangle. So the formula to find the area of the sector is half times r squared times theta, and to find the area of the triangle is half times r squared times sin of theta, sin theta. So we can factorize that into half times r squared times in bracket theta minus sin theta close bracket. So all we need to do is just put in the numbers. So here the radius is 10 centimeters, so 10 square. So this needs to be in radian, and since we have degrees, all we need to do is just times it with P per 180 and minus the sin of 30 degrees. And so 10 square will be 100 times with half will be 50 And here we can just cross this one off. So become 1, here 6. So this will be 3.14 per 6 minus sin of 30 degrees is 0.5. So 3.14 divided by 6 will be 0.523 minus with 0.5 will be 0.023. And then we just need to times 50 with 0.023, which equals to 1.15 centimeters squared. Next, we are going to talk about finding the perimeter of a segment. So, all we need to do to find the perimeter of a segment is add the length of the arch with the length of the chord. So, we already know how to find the length of the arch. So, all we need to do is find the length of the chord. So to find the length of the chord, we can divide this triangle into 2, and this will be theta per 2, and this will be theta per 2 too. And this 2 part of the chord, we can just label it x and x. So because this theta per 2 degrees, opposite is x, so opposite to the hypotenuse, so it will be sin. So sin theta per 2 is equal to the opposite divided by the hypotenuse. So x per r. So if we make x the result of this equation, it will be x equal to r sin theta per 2. And since a chord is 2x, all we need to do is times it with 2. So it will be equal to 2r sin theta per 2. So that's how we get the formula to find the length of the chord. And for the length of an arch, we already know it, which is radius times theta radian. Now we're going to solve an example question. Find the perimeter sector if the radius is 5 cm and theta is equal to 60 degrees. And now I'm going to show you an example of how we can find the perimeter of the segment. So as we know, the formula of the perimeter of the segment is r times theta plus 2 times r times sin times theta per 2. So all we need to do is just input the number. So the radius is 5 centimeters. And here we need to be in radian. And here we got degrees. So all we need to do is times the degrees with e per 180. Then plus 2, the radius is 5 centimeter. And times with sin of the degrees 60 per 2. So we can cross this out, 1 and 3. So all what is left is 5 times 3.14 per 3, which is equal to 5.23 plus 2 times 5, this will become 10, and times with sin of 30 degrees. And sin of 30 degrees is equal to 0.5. So 10 times 0.5 is equal to 5. So all we need to do is add that up. 5.23 plus 5 equal to 10.23 centimeter. So the perimeter will be 10.23 centimeter. Thank you. So that's all our presentation for today. Thank you.